Today at SmithBotics, we'll be making this DC voltage monitor number VM2 from Jameco Electronics from a kit. We'll show you essentially the different things you need to know about the build, and then we'll show you essentially how it works and whether or not it will fit your project or not. So we'll give you a good, honest opinion of what we think, and we hope you stay tuned. Here we go. We're going to get into the build and review of this VM2 DC voltage monitor kit. 5-volt DC monitor, but oddly enough it says on the label for 12 volts, 8 volts, or 5 volts, so that's kind of nice. Must be some jumpers or something. This is from Jameco Electronics, a company I've got a few things from. Got a whole bunch of kits from them recently, so oops, don't want to mess with the packaging too much. Just gonna be respectful of that. Okay, let's open this bad boy up and see what we have inside. So this is the Jamco part number. It's funny how they always put a little piece of tape on all the things they ship to you. And here's our parts contained within this bag. Okay, so these are the components. Got a couple ICs here, a pot, of course LEDs, since this is pretty much an indicator circuit, a bunch of resistors that are needed. I don't see any other parts, but that should be a fairly straightforward circuit. This is the instruction guide. It appears. Okay, so if you want to build your kit for 5-volt operations, use this instruction set. For 8 or 12 volts, use proper sheet. So, okay, so it gives you different ones. This is for an 8-volt DC monitor. And, okay, that's for the 12-volt DC monitor. Okay, well, that's not bad. So if you want to make it for different voltages, maybe there's a different series the way you connect it, or you leave out certain components, but that is nice to have. So nice little printed sheet. I'm going to actually do this one for 5 volts, so that is nice to have. So no kit will be repaired until repair fee is received. Well, okay, that's this little notice essentially, but then we get into the actual instructions here. Okay, well, first off, I do like that they do include the schematic. That does help you in troubleshooting, and it's always a good thing to see in any sort of kit instructions. You've got a nice parts list. As with a lot of the kits for the resistors, it does kind of break down the colors, which is handy if you don't have a chart, or just, for quick reference as well. Okay, so yeah, trimmer pot, resistor, LEDs, two ICs, 1N4148 and LM324 ICs. Oh, actually, those are diodes, I believe. Actually, maybe not. I'll have to find out. PC board, of course. It gives you, actually, this is nice as well too. Gives you an indicator for the LEDs, what is the actual voltage it would be indicating, and it gives you, pretty much the board itself, so you can see how everything is connecting. I believe it should be silk screened as well. And just some other instructions here. Okay. Place all boards on the fiberglass part of the PC board, in case you weren't experienced with that. I guess that's a good notation for a lot of people getting these and haven't done kits like this before. Let's just dump everything out. See what we got. I'll be able to be careful with that. Don't want to shock anything. I don't have a band on. Okay, so yeah, nice PCB board, printed circuit board. It does have some silk screening. It's not bad. So it's only one-sided board. Does have a net mask on it. Nothing on this side, just the silk screening. Not too shabby. Good quality. Okay, they've got all these particular LEDs together. I'll have to organize this just a little bit. I like to have these kind of laid out so I can just grab them in order. This is a series of some of the resistors. Okay, yeah, there's the diode. That's what it was. I think there's a couple diodes in there. Okay, so let me get this all organized and we'll get closer to setting up this kit. All right, I kind of laid out all the parts a little bit, labeled some of the resistors, just a little particular in that regard. So yeah, I checked out the board a little bit. Silk screening is okay. Again, just a one-sided board. The tinning looks okay. The pads look a little, they're fairly big, so it makes it a little easier, I guess, to solder them through. So no major issue. A little dull matte on that, but we're not buying this for aesthetic reasons. We're going to be utilizing this for a voltage indicator, essentially where the battery is at. The kit seems to imply that these are not pink, but actually red, so they'll probably light up that way. So sorry, Big Clive, that's not my favorite color. Red will be cool, because that would make more sense too when the power's getting down. And then we have your yellow and then your green. Green condition all good for the 5.2, 5.5, and 5.75. 5.0 is going to actually be one of those, and then 4.75. And then as you get into the 4.5 and the 4.25, these supposedly are going to be red, and that will work. They did package these ICs. Looks like on non-static foam here. They've got some nice IC holders with, of course, a notch to make sure you put them in the right way. Little potentiometer, and it looks like these are the two ICs we'll be using. Never seen anyone do this where they put kind of a foil thing here. It's probably totally reasonable, but just never seen that before. Maybe it just discharges or something on there, so it keeps it safe. But we'll go ahead, and the first thing we're going to do is we're going to start to put in the smaller components. The instructions do, as most kits do, tell you to start with the resistors. So we have some diodes here, resistors, for different different resistances here, and then we've got your set of the 390 ohms and your set of 1K ohms. So all in all, not a whole heck of a lot of parts to put together. So it seems pretty straightforward and nice instructions. So we're going to start to build this right now. Minor thing that I noticed in going over the instructions, I was looking at some of the components, and in the directions, besides your LEDs, the light emitting diodes, looks like there was 2 other diodes, but I got more than 2 diodes. I've got 4 diodes. So these 2 appear to be exactly, these 2 are probably exactly the same. I'll check them out just to make sure. But we have more diodes than what is called for on the 5-volt instructions. So kind of curious about that. So I did take a quick look at the instructions for the 12-volt, and all of a sudden now we have more. We have the Zener diodes listed here, excuse me. So, and we have also additional resistors. So I had more parts than I thought I needed per the instructions, and that's why. So you've got your variations of the 12-volt monitor, and then an 8-volt monitor, some variations as well. I think they knock out some of the resistors on that one. So some differences between how you wire it up, but I do appreciate that they do include both diagrams and the parts for it. So although it might be just a little more confusing for someone just starting out doing their first kit, I think that's a good feature to give you that flexibility when you have the kit to make it the way you want it. Even though it says 5 volts, you can make it for 8 or 12 volts, and they do provide the extra parts. So just figuring that little part out, only thing you need to worry about on that. But I definitely think that is a nice feature of the kit. About to do a little soldering here. We have the resistors in, of course, squirrely mess in the back, just bending the leads so that everything stays in there. I'll be soldering that up in a moment. A couple things to note on the direction. So, yeah, just had a little one here where it's like gras. What's gras for the colors? And then I remembered, oh, that's gray. So that's for that one there. No big deal there. This part, though, has got me a little stumped. First instructions: insert and solder all resistors. No problem. And jump. But I don't see anything referencing jump anywhere. There's no jumper leads, there's no 0 ohm resistor like you have in some surface mount components. I don't see any other reference to jump except for there, and there's nothing on the board that indicates any jumper point. So I'm not quite sure what that means. I'm not sure if that's going to be causing me problems. But I thought I'd point out, this is again on the 5 volt design. I looked on the other ones, and there's not a reference to the jump, just on the 5 volt DC monitor. So we're going to find out what that might be. I'm not quite sure. But I'm going to shut this off a little bit as I turn on the fan. It gets a little noisy, and we'll solder up some of these things and be right back. Okay, the noisy fan is off. I can take this out, and okay, it's always when you take it out you discover you missed one, and that's one I missed. I'll have to go back and touch that one up. I'm going to trim off all these leads, touch up that one missing one, and then we'll go for the next phase of soldering. I've got everything, at least all the resistors, and I also did the diodes. This is supposed to be step 2, but they were so small, there was only 2. I wanted to make sure I didn't mix them up, and these are, of course, important. You get the polarity right, but all the resistors are in. I used my trusty little jumbo-sized jeweler loop to make sure all the solder joints were okay. Don't have any solder bridging over. Sometimes important too, because you got the wires each different way, trying to keep it in the board, so you want to make sure they didn't cross over to something else and make a bridge. So next we're going to put in the potentiometer, the trimmer pot here, and then the 2 sockets for the ICs. We'll be almost done. Couple little things of note. When I was thinking about it, I thought, okay, it'd be diode 1, 2, 3, 4, 5, 6. But actually, no, diode 1 and diode 7 are the red LEDs. They look pink, but they're actually red. And it's actually meant to be on the lowest voltage level and then the highest voltage level. So if you're getting too low on power, it goes off as a warning. And too high on power, it goes off as well. Anything straying above 5 volts. So still didn't figure out what the jump is. And I also realized in the instructions, it never actually tells you to solder in the sockets. I don't know if they meant that. They thought that was some sort of, or that's what jump means. I'm not sure. But anyway, at least on the 5 volt one, I should have checked the 12 volt. You'll want to, of course, solder in the IC sockets. Do always appreciate when they have that on one of these kits or even on circuits, because it just, if you have a faulty IC, then it's easy to pull it out and replace it. So just a couple little things of note. We're going to get these soldered in for the LEDs, and I think with some power cables here, we'll be ready to rumble. So almost there. Oh, my bad. Actually, they do have it listed. So you put in the diodes, and then essentially you also put in for the IC too. So just a little cautionary note on the green LEDs, which came kind of bound up in this cardboard here. Remember the red one, the yellow one, they're pretty straightforward. They have a pretty unique longer lead for the positive connection, and then a little shorter lead for the cathode or the negative connection. These green ones, for some reason, maybe one of it is like a micro milli something longer, but pretty much they look the same. But the alternate way for these LEDs, of course, to know which side is cathode or negative is to look for that flat part. And they did, of course, note that here, so you can match the flat part of the LED up to the screen silk on these two. So just something to be wary of in this particular kit. They don't really have the longer positive lead marked that well on those green ones. Little things to point out about the kit and the LEDs that come with it. The red and yellow ones have these little standoffs that kind of keep the LED at a certain height on the board, so pretty much positions them for you. The green ones do not, so those were kind of odd. They're different kind of in the way they're set up, and they didn't have the longer lead and everything, so you kind of have to bend them a little bit. As you see, it didn't do that quite perfectly, but if you wait for perfect, you'll never finish a project. So I'm going to go ahead with that. I was probably a little rough with this one here. Actually, this one here, I think I tore off part of the pad, but I think I've restored that because the other part was there, so it's in there pretty good. I'm not going to mess with that too much. Of course, there's two leads that you do connect for power, and that's what you're going to be measuring with the meter itself. So I decided to put a couple of little small test leads on there so I can just easily hook it up first to the power supply, and then later on to whatever device or battery pack I'm looking to measure the power for. So just to make it a little easier for my purposes, at least right now. It's not a permanent. I could just cut them off later and attach it directly to something as needed later. So I'm going to put in the chips now. These, of course, always have a little notch on the IC chips. And in this case, the notch is on the left-hand side. So you'll want to match up the notches that are on your integrated circuits with that. Take it out of this foil thing, which again I haven't seen too much of. And we'll stick those into our little sockets here. Trying to be careful not to bend those leads. And as usual, they're usually just a tad bit off, so I'm just going to give it a slight push there and a slight bend there. That's the pressure of being on camera. Okay, I think those are in. Nope, they're not quite in. Okay, well, I'm going to check these out a little more thoroughly. Make sure I've got them in right. I don't want to rush anything to get on camera and get it. Oh, yeah, like I'm doing right there. So I'll be back in a moment. Okay, now I got those perfectly aligned. And in goes the chip. I'll put in this other one and we'll do some tests. Okay, here we are at the point. Everything is completed. I've got the ICs are in, LEDs all set, diodes, resistors. We got a pot here that I'm supposed to adjust once we turn it on. Haven't turned it on yet, so I want you to be part of the experience, whether it goes up in flames or works perfectly. Let's move these two leads a little farther away from each other. It's not too safe, obviously. Okay, and I've got this hooked up to a variable power supply. I'm going to hook it up initially to 5 volts, and here we go in 1, 2, and 3. Okay. I'm not seeing anything going on here. Okay, I'm going to power it down for a moment and see what's going on. There's no obvious reason. I'm going to try another power supply just in case. This one provides constant 5 volts, and 1, 2, 3, and nada. Okay. Well, this is a good case study, it appears, in troubleshooting, because something's not working right. Turn the lights off here a little bit to see if maybe it was just too dim, but it is not. So I'm going to have to recheck everything. Maybe it's something to do with that reference to the jump wire, so we'll find out. First part of troubleshooting, of course, is you want to check your circuits and all that, but I was pretty sure everything was okay. All the traces were good. I've already looked at it. So I did have that question about the putting in all the soldering the resistors and jump, and I couldn't find it anywhere. I thought there would be some sort of symbol or something, but turns out there it is. So they want you to put a jumper wire between these two terminals. Normally, when you go for one of the other voltages, that would be, it appears, this little diode here. So that's going to be what I need to essentially put a jumper on. I believe that should be it. So I'm going to go ahead and do that now that I've read the directions and discovered where that mystery jump was. That apparently is probably what's making it not work. So when in doubt, reread the instructions. I'll be back hopefully with a fixed circuit. I've got the new jumper wire in there. I'm going to solder it up now. It shows yellow since I highlighted on there as yellow. Why not? So I'll solder that up, and hopefully this will be our fix that will solve the issue. Okay, we have the jumper wire in place. This small little solid yellow jumper wire in the back. I've got the variable supply back in line, and we're going to turn that on in 1, 2, and 3. All right. Okay, well. Okay, let me turn off the lights a little bit so I can actually see essentially what it's doing. Okay. Looks like we got everything going on here. I'm going to lower the power just a bit. Okay, so this is 5 volts. Doesn't seem like that. 5 volts should be reacting that way with all the lights on. Now, there is an element where I need to adjust that pot. So 1 second, let me grab my tool, be right back. My variable power supply is at about 5 volts. Let's see if adjusting this pot makes any difference here. Oh wait, no it did. Not exactly what I expected though. I did have you put, which I thought was weird, red here and a red here. Essentially, let's see, the orientation should be like this. So LED 1 is triggered at 4.25 volts. So if it goes down too far, you'd think it would be hitting that. I don't think it is. Looks like we're actually okay in that. If I adjust down the power supply a little bit, they start to go off. But then, yeah. Okay. But maybe I need to hook up a multimeter here. Multimeter on this thing to see. Essentially, I think I'm probably at, let's see, probably at 4.25, but this is an analog power supply. So if I go up a little bit, that could be at 4.5. That could be at 4.75, which these are supposed to go on in those increments. And then that could be at 5. Next one up would be 5.25, but then it kind of looks like, okay, 5.25, and then we get into the danger zone at 5.5, and then, hey, you got too much power here at 5.75. So that might actually be working, but let's get the meter just to be sure, because my analog power supply just has a little dial, and it's not as precise. So we'll check that out on my multimeter. Hooked up to my multimeter. Currently, I've got the variable power supply pumping out 3.843 DC volts, and the first light is the only one that is on. According to the diagram, that's supposed to be 4.25 volts, so I thought, well, maybe I just need to adjust the pot, but it's down all the way it can go, and if I go the other direction, then the lights start to go up, so it seems to be going in the wrong way. So, I mean, actually for my purposes, 3.84 is pretty bad, so for our 5-volt circuits, obviously. That's not going to be very good. So if I were to raise that up a bit, now it's at 4.1. The yellow light goes on. That's supposed to go on at 4.5 according to the directions. Go the next one up here. And the green lights are really kind of dim, but it is on at a 4.28. That one's supposed to come on at 4.75. And going a little higher, 4.64 is this green light here in the middle. Now coming on, again, kind of, bright-wise, they're not really good comparison. And then beyond that, oh, a little too far. Okay, 4.89. Let's get up to right up to 5. Okay, I'm at 5 volts, and the yellow caution light is coming on, even though we're at the prescribed voltage. Okay, I might want to swap some of these out. Maybe I want to change the trimmer pot value a little bit, so I get these more in line with what I really want. I mean, I guess I can understand why they want to have the red if it's the voltage is way too low and if the voltage is way too high, but I've got a perfect, almost perfect 5 volts, and that's what this is supposed to be measuring, and it's telling me to be cautious about that. So I'm not sure why. Okay, let's raise it up a little bit more until we get to the next light. Okay, now we're at 5.19 volts, 5.15, about 5.18. and the red light is on. So I can see you're getting a little higher voltage than which you should normally have in the logic circuits that this will be powering. But I'm not too sure if I like the way they set this up, and something that's not working so far as the values. This might need to change this value here so the sensitivity gets more in line with what I would be expecting here. Yeah, it's not bad. I could probably work with it, and I might want to get some different green LEDs. These are kind of dim, or get ones that are dimmer for these so that it works a little better. So kit was kind of enjoyable to make, a little different results than I expected on the 5-volt module. And yeah, I wish this trimmer pot would affect it more. I don't know if changing that out would really do anything because the gain is really going the other way. So if I pull this down here now to 3.35, that's funny. I could turn the pot up, turn it all the way down, all the lights go off. But if I turn it up at this 3.35, just barely lighting on that one. You can't even hardly tell it. It is, but it is. I dim the lights a little bit for that. Yeah, when these are lit up, but you really can't tell. It's pretty low power, of course. So if I bring it back up, 4.16 volts, then there you go. So this is kind of a interesting project, but I mean, it really all the way down, I guess, gives it some value because that 5.17 is too low. That should still be this is 4.33 volts, 4.34. That's turning green, like it's okay. This is 4.56, still not okay in my book. 4.8, not okay because you need the 5 volts. And then at 5 volts, it gives you a cautionary yellow. So I might swap these out a little bit, make it make more sense for my purposes, to different colored LEDs. So I could probably still use it, but I'll just caution you a little unusual aspect in that respect. So if you are doing the 5 volt, definitely want to make sure you figure out that little jumper part. Perhaps this might work better on the 12 volts. There's a few other components you do put in. You put in you put in an actual diode there instead of this. So perhaps that might be a little better if performing circuit if you're using 12 volt. And there's also if you want it an 8 volt, it's kind of an odd voltage, but an 8 volt DC monitor as well. So perhaps it works a little better on those, but not bad. I still can modify it a bit for my purposes. I just hate that I'm at the optimum voltage of 5 volts and it's telling me, okay, you've got a cautionary yellow light here, which doesn't seem to make sense. A little higher, I could see 5.3 volts now. You're riding a little hot there, so that I can see, but I would think I would be pretty good at 5 volts, not to get that yellow light. Some final thoughts on this kit. I'll make a few notes here for myself. This is the from Jamco. It's the VM2 DC voltage monitor. I'm giving it kind of a B-, just because of some design elements. To be fair to Jamco, I kind of assumed with the LED function of kind of keeping an eye just visually on the battery without the exact voltage and all that, that it might be somewhat of a design of a chasing LED, so they would go to certain levels But yeah, it really bugs me that even at 5 volts, not only is this yellow caution light or orange caution light on, probably yellow, I mean, that's the desired voltage, and it's saying, hey, you might have a problem here. So, I mean, you could always swap these out, I suppose, but even on the lower range, it's telling you there's a problem here. Would have been better designed. Yeah, I know these were quadruple operational amplifiers chips that they used here, but I think I would have appreciated the design more if it would kind of go up to, you know, various levels, like, oh, you're in optimum range, okay, you're getting a little high here, or you're getting a little low here. So, but in fairness to Jameco Electronics, you know, their description was very, very sparse, and I didn't care. I just wanted to get a kit. I thought maybe I kind of projected on there how it might be designed. So it's not really so much their fault as maybe the buyer beware. I should have read the description or just investigated a little farther. Maybe checked out a YouTube video review. Yeah, it's not that great for me. I mean, maybe if you had something that measured voltage and it was like a water level, that might work. You could swap out the LEDs that way, but to me, this won't function for my purpose. So maybe I'll redesign something myself if I get to that point where I have proficiency enough to do that. But yeah, probably a B- for this. And if this isn't acceptable to you, so far as, you know, always showing the low range and kind of building up to this point, 5 volts is actually wrong. Maybe the 8 volt, 12 volt works better, but I'll just give it a B-. But thanks for watching the video, and hopefully this helped you if you're looking to buy a kit. Maybe this will fit your purpose, you know, if you can see a way to kind of configure that, or if you don't mind the way it's built. So I won't say, you know, don't buy it, because it's a personal decision, but just wanted to give you my opinion. So hope you had a enjoyable time at least seeing the project, but thanks for watching. Take care.